In the last video, we learned how to extract the root. Now we're going to use that to solve equations by doing something called completing the square. Now, this is the homework that corresponds to the completing the square part. Let's say that you have a binomial wrapped up and raised to the second power. Well, anytime you square something, you multiply it times itself, correct? FOIL this guy out. You're going to get an x squared in the front, you're going to get a squared in the back, and the outers and the inners are going to give you a times x and a times x. Because you're multiplying the same thing times itself, you're always going to get the same thing with the outers and the inners, which gives you two of them, and that is key because we want to figure out how to create a perfect square trinomial so that we can take this perfect square and go backwards and write it as blob squared, okay? So anytime you have the square root in the front, the x squared in the front, and some number in front of x, notice that the number in front of x is double something, and it's double the guy in the back before it gets squared. So we're going to take the number in front of x, we're going to take half of that, we're going to wrap it up and square it, and then we're going to add it, and that will give us a perfect square trinomial. We're taking half of double A, that gives me A, then we're squaring it and putting a plus in front of it to create a perfect square, and then we can go backwards and write it in factored form. For example, if I have x squared plus 6x and I want to add something to make it perfect, then I'm going to take half of this 6, which is 3. I'm going to square the 3 and add it. Now I know 3 squared is 9, but if I write it as 3 squared, after I add it, just keep it like this, then I can just write down my answer. I have the x in the front, the 3 in the back, and this sign right here, the plus, is in the middle, and that makes a perfect square. And if you don't see it, what you need to do is write down x plus 3 times x plus 3, FOIL it out, combine like terms in the middle, and you'll see that you get this. Another example, what if this guy is not even? What if he's subtracting? Well, 7 is just a number. Half of 7 will be 7 halves. Half of a negative number is a negative number, right? We are actually adding a negative 7 halves. But guess what? We're squaring it. So it's going to be positive at the back end. So when I write it down as my square, my perfect square, this sign right here comes from this sign right here. The 7 halves is just the 7 halves, okay? So you'll see that in my examples, I take half of that number, write it down in parentheses with a square, and I just copy this middle sign here because I understand that this is negative, okay? So I end up with the x in the front, the 5 halves in the back, and whatever sign was in the middle is what I know I started with. Perfect square. Now, completing the square is so useful for a ton of things. If you're going up through the calculus series, you're going to have to be able to rewrite certain things in a different form, which is going to require you to understand how to create a perfect square. For us in this class, we're going to be using this to solve problems that we can't factor. Now, if this was a minus, I could just factor it and set the factors equal to 0. But because it's a plus, I can't factor it. There are no factors of 5 that add to be 4. So I have to change my tactic and use a new way to solve this problem. So I'm going to take this 5 and get it out of the way. I'm going to move it to the other side, which makes it negative. That leaves me the x squared and the x term. I'm going to take half of 4, which is 2. I'm going to write it down, square it, and put a plus in front of it. That's all I did. But because I have an equal sign now, I have to do the same thing to both sides of the equal sign. So I took half of 4, squared it, and added it to both sides. The next step, right, take half of 4, square it, and add it to both sides. Now this is a perfect square. It's an x in the front, a 2 in the back, and a minus in the middle. Perfect square. Calculating what we have on the right hand side, I have minus 5 plus 4. That gives me this, which is just minus 1. Now does this look familiar? It looks like what you did when you extracted the root. And that's exactly what I'm going to do. I'm going to take the square root of this, and it gives me this stuff in the blob. Take the square root of this. What's the square root of negative 1? I. And don't forget the plus or minus. So now I have the stuff inside the parentheses equals plus or minus I, and I just add the 2 to both sides, and now I have my answer. Notice that I get 2 answers, both complex. I started with an x squared, so I have to get 2 answers. Another example, x squared minus 3x equals 11. We've already got the constant to the right. I'm going to take half of 3. If you can't divide by 2, then you just write the fraction with 2 in the denominator. Taking half of something is multiplying by 1 over 2. Got it? I'll say that again. Taking half of something is multiplying it by 1 over 2. Here's my little thought bubble. Half of 3 is 1/2 times 3, which is just 3 over 1, right? So if you can't divide by 2, you multiply by 1/2 and leave the 2 in the denominator. So half of 3 is 3/2. Square it, stick a plus in front of it, do the same thing to the other side. Rewrite this as a perfect square. I have x in the front, 3/2 in the back, and a minus in the middle. And I've got a perfect square trinomial. I don't have to factor this. I can just write it down. I created this. I did it for a reason, and I know why I did it. I know that I was creating a perfect square. So I don't have to think about this. All of this is very mechanical. Okay? You're just writing it down. On the right-hand side, I have to square this guy out. Now, squaring a fraction is just multiplying it times itself. So you multiply 3 by 3 on the top and 2 by 2 on the bottom. You're just squaring the top and squaring the bottom. So I have 11 plus 9 over 4. Common denominator means I multiply this by 4 over 4. It gives me a 44 in the front. If both of my denominators are the same, I only need one fraction. 44 plus 9 gives me 53. So this equals 53 over 4. Now I take the square root of both sides, and that gives me this stuff inside. Take the square root of this. Don't forget the plus or minus. Anytime you take a square root, you have to say plus or minus. If the root's in the problem, it already has a sign. But if you take the square root, you have to put the plus or minus. Don't forget it. And when you take the square root of a fraction, it's the square root of the top over the square root of the bottom. So I have root 53, which doesn't reduce, and I have the square root of 4, which is 2. Notice that that gives me a common denominator. Almost every time it does. And now the only thing I have left to do is to isolate the x by adding 3/2 to both sides. That gives me this guy right here. And since it's a common denominator, you can also write it as one fraction. So let's talk about the steps now. I'll write them in green. Step number 1, I want to move the constant to the right-hand side. When I do that, I want to leave space to work. because step 2 is going to be to take half of the number in front of x. That's just the plain old x term. Square it and add it to both sides. Wait a second. Hold on a second here. Both sides. One thing that I made a mistake about. We're starting with step 2. We'll talk about step 1 later. All right, now what we, okay, we're taking half of the 8, which is 4. Just write it down. This is very mechanical. I'll be writing it in the blank when I do it for myself up here. So I take half of 8, write it down, put a square on it, and put a plus in front of it. And I have to do that to both sides of the equal sign. Remember, when you move the 5 over, he becomes negative in this case, okay? So this is done. This, I'm going to calculate. 4 squared is 16. Negative 5 plus 16 is 11. This is now a perfect square. The fourth step is to rewrite the left-hand side as a perfect square. And I want to calculate the right-hand side. I already did that here. Right-hand side. Evaluate it. So we evaluated the right-hand side and we got 11. And now we rewrite the left-hand side as a perfect square. You got the x in the front, the 4 in the back. Notice that I could have written what, plus 16. I would have had to take the square root of that. If I leave it like this, I'm just copying my 4. That works a lot easier than squaring it if there's a fraction there. You're just copying what's in the parentheses. And I had a plus in the middle, which goes right here. So I have perfect square equals 11. The next step is to do what we learned in the last video, extract the root. How do you do that? You take the square root of both sides. Don't forget plus or minus. And then you solve for x by isolating it. Okay, so what did we do? We took the square root of the perfect square and the square root of the 11. We got the stuff in the parentheses. Don't forget the plus or minus. Square root of 11 is reduced and simplified as much as possible. And the only thing I have left to do is to subtract 4 from both sides. And that gives me 2 values of x, the plus value and the minus value. All right, now, so far, these have all worked the same way. Sometimes we got a fraction. We see that it's not a big deal, right? Let's see what happens on the next page. Okay, so far, all of the problems that we've done didn't have a coefficient in front of the x squared. What if you do have a number there? Well, this is where step 1 comes in. Step 1 is to divide both sides by the coefficient of x squared. Then we're going to just follow all of the steps that we've done previously. So step 1, in this case, I'm going to divide everybody by 3. I'm also going to take this chance to move this guy over to the other side. So watch what I get. the 3 divided away. 6 divided by 3 is a 2. I'm going to leave myself a space, and 27 divided by 3 is 9. Moving it over, I'm going to get a -9. The next step is to take half of 2, which is 1. Let me do this in blue. I'm going to have a 1 squared and added. Now I know 1 squared is 1. So do you. Actually, half of -2 would be -1, but when I square a negative, I get a positive, right? So I'm just squaring the number and adding to both sides. What do I have now? This is an x, a minus in the middle, a 1, perfect square. Do you see what I mean by it's very mechanical? You're just copying what you had before. If you understand the structure of it, you don't really even have to think very much. Now, simplifying this gives me a -8. Right-hand side is -8. Now I extract the root. Take the square root of the left, it pops out. Take the square root of the right, don't forget plus or minus. Now you never leave the square root of a negative, you never leave the square root of an 8. What is this? Well, we have an I, the square root of a minus, right, is an I. We have the square root of 4 times 2. So that's going to leave me with the square root of 4 is 2, the square root of 2 is 2, square root of a minus gives me an I. My last step is simply to move the -1 over, and it becomes +1. Plus or minus, that I forgot, sorry, plus or minus 2 root 2 I, and I'm done. So if you have a coefficient in front of the x squared, you have to divide it away. Now in this case, it divided evenly, and I had an even number in the middle. So the problem worked out nice and neat. Let's do one that's not so neat. So again, 2 things at once. I'm going to divide away the leading coefficient. It divides everywhere. And I'm also going to take that guy and move him over. So what I have is x squared minus 5 halves x, leave a space, minus 1 half. Now, what do I get when I take half, here's my thought bubble, half of 5 halves? I can't divide 5 by 2, so I'm just going to multiply the bottom by 2. If you can't divide, just double the denominator. You see that you're just multiplying by a fraction. You multiply straight across the top, straight across the bottom. So that's half of the middle number, and I'm going to just, I'm going to say plus parentheses squared 5/4. I couldn't divide 5 by 2, so I doubled my denominator. Your dividing by 2 is the same as multiplying by 1/2. All right? So what I have now on the left, I created it. I know what it is. I can just write down the answer. Perfect square trinomial with an x in the front, a minus in the middle, 5/4 in the back. Now on the right hand side, I'm going to do a little calculating before I write down my answer. I had minus 1 over 2 plus square the 5, square the 4, Now I have to get a common denominator. I need a 16, so I got to multiply the bottom by 8. If I do that, I have to multiply the top by 8, and that's going to give me minus 8 over 16 plus 25 over 16. 25 minus 8 gives me 17 over 16. That's my right-hand side. Now when I take the square root of that, I'm going to take the square root of the bottom and the square root of the top. Don't forget my plus or minus. Square root of 16 is 4. And now I get my x alone by adding 5 over 4 to both sides. Notice that I have a common denominator, and I choose to write it as one fraction. Okay, now I'm going to write out all of the steps, and this works for any trinomial no matter what. So I'm going to show you on any trinomial you can use completing the square to solve for x. So if I have any trinomial, then it doesn't matter what these numbers are. So I'm using ABC to represent those coefficients, and it equals 0. So my first step is to get rid of the leading coefficient. If you don't save any page in these notes, save this page because it has all of the steps written out here. So I'm going to divide away the a. That gives me x squared. Now I don't know what b and a are, so I can't reduce. So I just get b divided by a here. Same thing here, c over a. I'm going to divide the a away, and I'm going to move the constant over to the right-hand side. So now he's negative, and I left myself a space to work. So once you've moved the constant to the right-hand side, you're going to take half of the number in front of the x. In this case, I don't know what it is, but taking half of that number, I'm going to put a little thought bubble here. 1/2 of b over a is just b over 2a. That's what I'm going to square and add to both sides of the equal sign. So this guy right here, I have created a perfect square. I don't have to think about it. I don't have to know what those numbers represent. I can just write down what it is. Okay, I have an x in the front. I wrote that down wrong. Hold it, that's a 2. There we go, the rest is correct. So here we go. I have an x in the front, a plus in the middle, and b over 2a in the back, and it's a perfect square. I know that because I made it. On the right-hand side, I have to calculate this thing out. So the first thing I'm going to do is square b over 2a. And I'm going to make another little thought bubble over here. I had b over 2a, and I squared it. Well, that's b over 2a times b over 2a, right? I'm just squaring the b and squaring the 2 and squaring the a, and that gives me b squared over 4a squared. So when I'm calculating the right-hand side, I square this out. It gives me b squared over 4a squared. Now you see I need a common denominator. So 4a squared is my LCD. I need a 4 and another a here to make my denominators the same. So I multiplied, let me stick this in here. I multiplied this by 4a and 4a to give both denominators 4a squared. So you see what I got? I got 4 minus 4ac and a positive b squared, and everybody was over 4a squared. That's this. Now, I'm uncomfortable writing numbers with a minus in the front, so I'm going to flip the order of this when I write it down in my answer. Put this back where it was. Whoops. There we go. So I'm going to take this and write it as b squared minus 4ac. Is it starting to look familiar a little bit? It should. So I've got this, I've rewritten this as a perfect square, I've calculated the right-hand side and gotten this, and now I'm ready to extract the root. So I take the square root of this and get the stuff in the parentheses. When I take the square root of this, I've got plus or minus. I'm going to take the square root of the top and the square root of the bottom, which gives me a 2a in the bottom. Now it should really look familiar. And the last step, b plus this guy right here equals plus or minus the square root over 2a. All I have to do is subtract this from both sides, and they both have a common denominator, so I make a single fraction. I end up with minus b over 2a plus or minus b squared minus 4ac, the square root of that. And look, it's one fraction, and I have developed the quadratic formula just by completing the square for any possible trinomial equals 0. You're welcome. Okay, so the homework for this little bit of 1.5, we're doing the B part, and the homework is in 1.5, and it is 47 through 63. This is just completing the square. Practice the crap out of this stuff, guys. And the next video will be about using the quadratic formula.